The world was stunned in 1997 when Deep Blue defeated the reigning chess champion Garry Kasparov. By calculating millions of possible combinations, Deep Blue was able to outmaneuver Kasparov to win the series 3.5 to 2.5. That surprise was compounded in 2017 when AlphaGo defeated world champion KG at the game of Go. In Go, it is impossible to calculate all the possible board configurations. Many argued a computer could never play the game of Go, let alone win against a top human. Fast forward just a few years to BlizzCon 2022. The top human players will finally face a credible artificial intelligence at the game of StarCraft. The number of possible actions are practically infinite, which makes even the highly complex game of Go look like checkers. Yet again, humanity is crushed. Not a single human can mount a defense against the AI. What's strange is that its playstyle is almost human, yet unlike that of any human. It seems to understand the game. How did we go from calculating chess moves by brute force to artificial intelligence that can think strategically in a mere 25 years? Welcome to this class, everyone. This is Reinforcement Learning in Motion, and I'm your instructor, Phil Tabor. The era of highly sophisticated AI is rapidly approaching. While beating humans at a real-time strategy video game may not sound impressive, it's only a few steps removed from more relevant tasks. Business strategy, actual warfare, and resource management are just a few areas that share common factors with real-time strategy gaming. Creating tools that can bring humans new insights into these and other areas will be a valuable skill for developers for the foreseeable future. In this course, you will learn the fundamentals of reinforcement learning. We will start from the very beginning, from the mathematical theory, all the way to the practical implementation of these agents. We will use a number of games to illustrate the concepts, and some of those we will get from the OpenAI Gym. If you're not familiar with it, the OpenAI Gym is a massive collection of games for artificial intelligence. Everything from classic problems in the reinforcement learning literature to a massive catalog of Atari games is included. In this course, we won't get to the Atari games, but we will tackle a number of problems from the classic reinforcement learning literature. We will also learn which types of algorithms are appropriate for a given problem and when to use them. We're going to touch on Q-learning, SARSA, dynamic programming, Monte Carlo methods, and TD0 learning. This course is for the highly motivated student who is prepared to spend the time required to learn the material. We're essentially compressing decades of thought and research into a several-hour class, so expect a fast pace. You really need to be familiar with the basics of the Python language. You should be comfortable with classes, the built-in Python data structures, and list comprehensions. We'll be leveraging all of these things, so if you haven't seen them, please check out some tutorials on Python. It's also a big plus if you have prior exposure to advanced mathematical topics such as calculus and linear algebra. You don't need a PhD in mathematics, but if you've taken some combination of classes in these topics at some point in your past, you should be good to go. We'll cover what you really need to know as we go along, and occasionally leave more details in the course transcript for those that want to dig a little deeper. Your success is going to depend on what you put into the course. Make no mistake, it is a challenging topic. The flip side is that it's highly rewarding when you get it right. So please do all the exercises, not just the ones in code either. I'll sprinkle some conceptual quizzes throughout the course to make sure you understand the principles of reinforcement learning. I highly recommend you do these in addition to all the coding exercises. Note that in most cases, I'll provide my own solution to the coding problems in a video. This is just a sanity check for you. There's often more than one way to solve these problems, and your solution may very well be better. If your code works and looks different than mine, that's perfectly fine. This is a reasonably new topic, so questions on Stack Overflow are going to be few and far between, but please don't rely on it too much. Being spoon-fed the answer may seem great, but it really shortchanges the opportunity for learning. When questions do arise, please check out the forum for this course. Go ahead and ask your questions there, and I'll be checking it regularly to respond. That's all for now. I hope you're excited to get started with the hottest topic in artificial intelligence. In the next module, I'll give an overview of machine learning and its limitations. This will demonstrate the need for reinforcement learning.